journey to the cloud often begins with lengthy and expensive migrations, only to end with cost overruns and performance problems once you're there. But your journey doesn't have to be this way. Turbonomic's cloud migration plans show detailed comparisons of compute and storage costs, including reserved instance savings. Our consumption-based analytics accurately account for application resource needs. We'll show where you need to increase resource allocation to assure application performance and where you can safely size down resources, as well as purchase RIs to lower costs. You can compare the cost to run your applications across different public cloud providers or regions. Hi, I'm Brandon Combs and I'm a technical trainer here at Turbonomic. In this video, I'm going to show you how to use Turbonomic's cloud migration planning feature. Here we'll learn how to determine the cost and feasibility of moving on-prem workloads to the public cloud, including which instance family and size to use for each migrated workload, which storage tier to use for each migrated workload, how you can gain additional cost savings by scaling on-prem workloads before moving to the cloud, which workloads are candidates for reserved instance purchases, and the actions to take to put the plan into effect. There are a couple of prerequisites to running this type of plan. You'll need to have at least one on-prem or private cloud target, as well as at least one public cloud target configured. If I go to the Settings view and select Target Configuration, I can verify that I have at least one on-prem hypervisor, as well as one cloud management target. We'll start by selecting the Plan view from the left-hand navigation menu and choose to create a new plan. Here we're presented with a set of plan wizards and we're going to choose Migrate to Public Cloud. The first step in a migration plan is to choose the workload that you want to migrate. This can either be a group of VMs or a selection of individual VMs. For this example, I've already created a custom group which I've named Lab Migration Candidates. So I'm just going to search for that. Next, I'll select my group and click the Next button. The next step is to choose the destination for our workloads. We can either have Turbonomic evaluate all public cloud providers and choose the one with the lowest costs, or we can choose a specific cloud provider. Turbonomic will select the region with the lowest cost available for that provider. We could instead choose a specific region, or we could create a custom group of regions and choose that. For this example, we're going to select the AWS East Ohio region. So I'm going to search for East and select that region. At this point, I can either begin migration plan or I can configure a couple of advanced options. One of the options allows us to choose our OS configuration. The default Match Source OS to Target OS will include the license costs for running each workload in the cloud. You may be planning to bring your own license. If we choose this option, our cost analysis will include only the compute and storage costs for running the workloads. Or you may be replatforming as part of your migration. With this option, we can specify the mapping of how we're going to replatform our workloads based on their source OS and what the OS will be once they're running in the cloud. Additionally, we can choose whether or not we'll be bringing our own license. The other option allows us to choose our pricing. You may want to choose an account that has special discounts or pricing associated with it. If not, Turbonomic will select the account that has the best pricing available. Once I've chosen my advanced options, I'll select Migrate to Cloud. At this point, the analysis will begin, and after a few moments, we can see the results. Here in the results view, we can see that the plan scope includes our group, Lab Migration Candidates, and that we'll be moving these to the AWS US East Ohio region. And the supply chain shows the total number of workloads to be migrated. The cloud cost comparison chart shows us two sets of results. On the left, we have the allocation plan. This is sometimes referred to as a lift and shift approach. This is simply choosing the cloud instance family and size for each workload by using its on-prem resource allocation. We can see that taking this approach will leave us with performance risks for workloads that are already overutilized on-prem, as well as many missed efficiency opportunities due to underutilization of on-prem resources. We can eliminate these risks and missed opportunities by using Turbonomics' consumption-based plan. In this plan, Turbonomic analyzes the resource demand for each workload and chooses the instance family and size based on that demand. On-demand compute cost shows us what the monthly spend would be for all the workloads that were not good candidates for reserved instance purchases. Reserved compute cost shows us the amortized cost for all workloads which Turbonomic recommends purchasing a reserved instance. We can also see the total monthly cost for storage. On the allocation plan, this is using the cloud vendor's default storage tier, in this case GP2. The consumption plan shows what our total storage cost would be if we allowed Turbonomic to select the appropriate storage tier based on the IOPS demand of each workload. Finally, we can see the total cost of migrating to the cloud using either an allocation-based plan or a consumption-based plan, and the difference in cost between the two options. Now that we've determined what the total cost of migration would be, we want to identify the individual instance family and size for each workload. The Cloud Template Summary by Type chart shows the total count of each instance type chosen based on either the allocation-based plan or the consumption-based plan. If we click on Show Changes, we can see the individual VM to template mappings. Here we have a list of each VM to be migrated, and if we look at one example, we can see that running the workload using the allocation-based plan would be costly. However, if we use the consumption-based plan, we can run this workload at a lower cost. In addition to that, if we take the Buy RI recommendation, we can save even further. RI recommendations are not made for those workloads with insufficient uptime. A workload must be running at least 18 of the last 21 days to be eligible for an RI. Now that we've identified the instance type and RI recommendations for each workload, we want to know which tier of storage they should use. If we scroll down in the plan results page, we'll find the volume tier breakdown chart. Here we can see the total number of volumes placed on each storage tier based on each workload's actual IOPS demand. We can click on Show Changes to see the volume to storage tier mapping. For this volume, we see that if we use the default GP2 tier, it would cost $49 per month. However, the IOPS demand for this volume is very low. Therefore, we can use the SC1 tier, which only costs $12 per month. If this volume were placed on the default GP2 tier, it would cost $15 per month. However, this volume has a higher IOPS demand and we would likely experience performance problems. Using Turbonomics consumption-based data analytics, we've determined that it should be placed on the IO1 storage tier. The cost is going to be a little bit greater at $25 per month, but that cost is necessary to ensure performance. Next, we want to learn more about which reserved instance types we should buy. If we scroll down farther in the results view, we'll find the recommended RI purchases chart. Here we can see the total number of each RI instance type and size that we should buy. If we click on Show All, we can see the VM to RI mapping. For each RI purchase recommendation, we can see the VM which will utilize this RI, as well as the cost to purchase based on a 3-year all-upfront term. Great! So how can we see the actions that it would take to put this plan into effect? If we scroll back up to the top of the results view, we can choose to see the list of actions generated in this plan.
You can find this video and others like it in the How-To series on the Green Circle at greencircle.vmturbo.com/community/education/how-to. If you have questions or comments, please email certification@turbonomic.com. Thanks for watching.